So first of all, so this is going to be interactive. So anyone that wants to follow along, I've added a tiny URL there. So if you want to open that in your browser, tinyurl.com and then energy HPC. And if you click through on that, you're going to end up on this page, okay? So what are we doing here? So the objective here is simple, is to collaborate, putting together a standardized set of benchmarks. And this, even just saying any of those words are controversial. Like, first of all, collaboration in this industry is already a controversial term. Not to mind cross-platform benchmarking. We got loads of room here to make loads of enemies and friends and hate and all the rest. These are all sort of sensitive and difficult topics because it's complicated. And let's face it, it also is often when you're talking about benchmarking, particularly with multiple vendors, like we're sort of sticking our neck on the block here, like because there's plenty of room for people to be upset with us. So what's the objective? Well, our objective is to make you guys all be in trouble with us. So misery loves company. So what we're going to do, we go to the benchmarking session, like over near the coffee, because we'll need it. We're breaking this down into a set of questions, like what are the real sort of community questions that need to be answered? Like, can we come to a consensus on what these should be? This is a shared document, so, and if you scroll down to the end of it, there's also an acknowledgements, contributions, blame section, so if you want to continue to be part of the conversation, and hopefully this will evolve into being a collaborative project that will, like SEAM, for example, like one of these, joint types of projects that we all sort of carry forward and get some value out of it. Everything here is, it's editable editable for a reason. If you don't like something here, you should fix it. You don't even need a PR, but just to give you an example, okay? So we have seeded this with a few questions. So we're going to break people into tables, like whatever their favorite topic is, to have a good old discussion, fight about this, refine thoughts. But this would be, for example, like what are the kind of questions we'd like to answer? Well, first of all, just from a geophysicist perspective, like what are the most important benchmarks? Like isotropic acoustic, everyone does it as a first step. We teach all our PhD students to do it. It's useless to all intents and purposes. It tells you very little about the machine in terms of anything useful for production and productive workloads. So you want TTI, which flavor of TTI, different variations of TTI have a massive variation in terms of the amount of memory bandwidth that they use, how many registers they use, we have elastic, and so on and so forth. But we also can't go to the other extreme where we just run 100 benchmarks or 1,000 benchmarks with every conceivable time and space discretization across all PDs. Like then it would start defeating the purpose of what benchmark. Like you'll be losing the signal in all the noise or the information in terms of getting something useful. And also in terms of vendors, engaging with vendors, you can't expect vendors to implement 1,000 different benchmarks. So there's an optimization problem here to have the minimum number of benchmarks. And each benchmark, we should be able to answer a question, which is like, what's the learning outcome from this benchmark? So we've introduced yet another benchmark, but what information is it giving us that we didn't have from the other benchmarks? Does it have a different number of, does it have a different operational intensity? Or different memory bandwidth, different number of registers, whatever the heck, okay? But there has to be a rationale and a justification behind each one. And also, like in terms of even capturing it, like what information, if we standardize a benchmark, what information needs to be captured so that a problem specification is understood, it's reproducible. So in the first instance, inside of DeVito, we can have a concrete like implementation of that benchmark. But of course, like say X vendor then for a particular bit of hardware, they will want to get their own guys to do their own implementation of that benchmark that's optimized with their gurus and so on and so forth. And we have to be able to have the specification tight enough that we know that we're doing apples to apples comparisons. Now, as part of this, let me click on this, for example. So everything is linked through in the document, so you don't need to write this. So we already did a project on this with, kindly supported by Chevron, where we have implemented, let's call it, version 0. I've added a disclaimer, so right away before some hardware vendor comes up and gives me a slap, we have an initial set of results here based on the work that we've done over the last couple of months, where we've run across some CPUs and AMD GPUs and NVIDIA GPUs. But don't go making $1 million decisions and writing checks based on our information, right? I want to be very clear that this is work in progress. It needs a lot of eyes looking on it. And again, this is why we are opening this platform in terms of benchmarking. We're opening it up to get input. I think there's an issue here about you can't ask for trust. You have to create a mechanism where people can verify. So we've attempted to design a system here that tries to capture the specifications. So let's put in a few pictures. So for example, we put some thought into what's the anatomy of a standard benchmark. So for example, at the top bit here, you would have the problem specification. So what details do you need to include so you can get an intern and say, go ahead and implement this, whatever. This is exactly what the problem being specified is. This is what the grid points should be. This is what the boundary condition is. All the stuff that people forget to mention in a paper when they publish it and you're trying to reproduce the results. So again, this is why we're putting you into this enterprise. We don't want to have, rather than people saying, oh, we forgot to say such and such. Well, if we did, you can update that document and let's make sure that we get it in there. The middle chunk here then is these layers are all going to be concrete examples of the implementation. So with the Vito, we started doing this with the Vito Pro because, of course, our motivation was to show that the Vito Pro had awesome performance, so that's our concrete implementation. But because everything is based on GitHub Actions and everything is event-driven and extendable, the vision is that we'll extend this to include open source to Vito, but also then so the hardware vendors can start adding their own specialized benchmarks that just implement this standard. And now there's multiple, I think, additional interesting considerations here, which includes, say, in terms of reproducibility, the containers. You need to understand what the environment was, say, for even compiling and running the code. And you can get massive variations in terms of performance just by changing the compiler version or the environment. So again, part of the design here is to capture that detail, whether it's Docker, Singularity, easy install, or whatever else. It's quite a list of different ways that this can be done, whatever it is. Again, the community needs to decide, what those mechanisms are for capturing the execution environment. Then what are the target architectures? There's, again, a multitude of examples here. In our particular example, when we were doing this, we had some bare metal instances on-prem, also some cloud. But again, these are all sort of concrete implementations. And then the bottom bit then is where the standard comes in again. As in, okay, well, we've specified what the problem specification is output, but now what information do we need to be capturing? So again, whatever the standard is, you're going to encode it in a JSON file, for example, so everything can be scripted when you're trying to assemble results and put everything together. But what are the key performance metrics? My personal bias is that flops is useless. It tells you absolutely nothing. You could be calculating bloody zeros or anything. It doesn't really tell you anything at all. And this is what you even see at supercomputing very often. People are presenting results, and even for Gordon Bell prizes, where the flop count can easily be inflated. But for the energy industry, what are you really interested in? Well, you care about throughput. So in this concrete example, we just focused on gigapoints per second. But again, I think it's up to this community to decide, rather than just my biases, what are actually the performance metrics that you guys care about, what needs to be there. The fact is, all this information is very easy to capture, but we just want to make sure you're capturing the right information and publishing it. And then you include other things, such as, there's no point in calculating the wrong answer really, really quickly, no matter what anyone says. So this is part then of the problem specification, specifying the norms, so you can actually verify after running the benchmarks that you're actually only using performance numbers for runs that actually calculate the right answer, for example. And then there might be various other implementation-specific metadata that can be stored for whatever purposes. Now, in terms of the designs, there's a lot of complexities here, and the problem with any IT project is just the complexity blows up in your face. So we took the design decision to build everything upon GitHub Actions. And one of the simple, honest reason why we did that is because we're already heavily using GitHub and GitHub Actions for doing CI/CD. So it's already something that we were doing as part of our regular software development. So CI/CD has pretty much all the same characteristics of what you need for automating benchmarking this way. So there's self-hosted runners so that you can have your own dedicated hardware or cloud or whatever, rather than just using GitHub's cloud. So that's the rationale behind this. And the nice thing, again, as I said, is keeping the complexity of implementing all of this, particularly for cross-platform, it's keeping the complexity down, and then it's just reusing technology that I expect everyone is using anyway, like a version of CI. So we get to reuse our own expertise. Like, it takes a while to learn how to become proficient in using all of these things. So our first implementation, again, we're looking for things to play with. So far we've done this on a range of NVIDIAs. We were working with Oracle, we were working with AMD, and then we already had some hardware. So the advantage of why we're doing it this way is fully automated. Like, one thing that everyone here, I'm sure, is familiar with is benchmarking is a shed load of work. So again, this was all designed in this way, so it was automated. So we click a button and it just goes, like, sends everything out to a scheduler and let the scheduler figure it out. And then it's all event-driven in terms of collecting all the data and publishing the data onto a web page. So that's why we've done this. And because we've done it like that, then we've captured all of the details, including the containers, like the environment. So the dynamic, the behavior, if you like, that we're trying to stimulate here is that whoever the stakeholder is, whether it's a hardware company or a cloud company or, like, an oil and gas company, you can pretty much go in there and say, okay, I got this result. Like, is it kosher, or how did they get that? Why can't I reproduce it? But you can go in there and you can see the container, you can see how it ran, you can see all the logs, and you can start looking for differences. And then if we have messed up, and, like, say one of our benchmarks is off, well, again, a vendor can point that out. Oh, you've mucked up here, you're using the wrong whatever it is. We've found a multitude of exotic problems already doing this. But at least the hope is we can discover, or, like, we collectively can discover these exotic problems, like exotic problems with compilers and other things. But then if we identify it, and then we incorporate it back here, we have then captured that information, and the community gets the benefit again. So then the vendor is happy because, like, say, their result has improved, and we have identified the problem. People haven't done rubbish benchmarks. And then if you're an oil and gas person trying to do these benchmarks or running your own benchmarks, you have the benefit of someone else having discovered whatever odd compiler problem there is, or environment problem there is, or whatever. And I think the final bit, like, I'm just zooming through this, like, it's not a slide deck. I don't want to bore you with details that you don't want to know. But we've also then just designed so this is the kind of workflow that we envisage. Again, we need feedback in terms of how do we deal with maybe incorporating data where people have to run it manually. So sometimes things can't be automated. You have stuff behind some firewall, and for whatever reason you can't, like, get this hooked up for CI. So what does a process and a fair process look like? So what we envisage is that you would download the benchmark, so you can pull the benchmark a bit like the way that you might do LinPack. You run it on your own hardware. You can pull down the result. You can add your results manually and then do a PR, like a pull request for those that know Git. And then that just triggers in a manual peer review. So, like, reviewing a paper, basically going through, does this result make sense? Have they done everything? Are the logs there? Does everything look okay? There might be a revision process if there's any questions or data is incomplete. And then once we pass all of those checks, we approve and merge, and then the GitHub action then is triggered to publish the pages. So we try to have a review process, and this could also then be a mechanism if you want to add a new benchmark. So again, it's trying to introduce a peer review, but again, the details of how that's done, I think it needs to be informed by the community. So the homework then is, I know that I've gone on for too long, and thanks everyone for your patience. But the plan for the morning is Keith is going to take over, and those of you that came to the Keith session will get back onto the agenda and talk about the stuff that you originally thought you were talking about. We're going to go, the benchmarking people are going to go next door close to the coffee. We're going to figure out how to break ourselves up into groups that are going to argue and fight about what the details of this and start populating this diagram, this file rather. And then for the last half an hour, we're going to come back and join you, and hopefully we'll get representatives like across the community to speak to these individual points and give you a quick summary, and again ask for the feedback. So the key point is, the very first session at the very start of this conference was above talking about community collaboration. Very often people talk about it not coming around or the difficulties. Sometimes the way that you get collaboration to happen is just to start doing it rather than just talking about it. So we really strongly encourage all kinds of positive and negative feedback here. Keith, anything to say on that?
Thanks very much, Gerard. We will get back together probably at about 11:30.
Yeah.
And have the conversation, and then try to come up with action items that will force our community to continue this effort.
Mm-hmm. Yeah, and I think that's the key point is action. It's very easy to identify problems, and we should be identifying problems, but we also have to try to be constructive about, well, what are we going to do about it? Does anyone have any questions before we go? Is now a good time for any questions that might influence us for that?
One thing that I see is also using these benchmarks, for, I guess, as a toolkit to check a cluster.
Yeah.
Right? Just a benchmark and say, yeah, that's about the performance that we're expecting.
Yeah. So that's a fabulous point. So the point being made is that this has multiple uses. It's not just about purchasing, but I think it's optimization, but also as a diagnostic tool. And you're absolutely right. Like say even on the run up to this over the last month, there was we were getting different results between our A100 and then the A100 as on Oracle. And then it was great. We were saying, why the heck is there a 20% performance difference? And then it did stimulate then to, go in there and look. We found what the problem was, fixed it, and then, we got the same answer now. So, yeah, as a diagnostic tool. Yeah. 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 Yeah, I strongly agree with that. Okay. Time to get to work. Oh, yeah, sorry, another question.
Piggyback on that and just say, when you're doing those benchmarks, think about the runtime of them. If you want to use them to check your cluster, probably don't want them to be hours long.
Sure.
So if you can make a micro benchmark checking hardware,
Yeah.
runs as short as needed.
Yeah. And that's something, so we need to capture that in our next discussion, because at the moment, we're guilty of having overloaded benchmarking with auto-tuning. So in this current result, our benchmarking is too heavy because we've stuck in an auto-tuner there as well. So that's something that needs to be looked at and pulled out because it can't run for an hour. Good point. John?
I wanted to jump on what you said. I think it's interesting to think about maybe the whole problem rather than just pure propagation. Like once you've loaded up a GPU, how fast is the GPU running? There's the bit where you, in DeVito's case, you compile the equation, right? Set up the equation, solve the DAG, write the system of equations, compile that, and then load it up GPU, and then you're propagating.
Mm-hmm.
So I'm not sure it's fair just to count that part where you're only propagating. It's like we need to also be thinking about
The whole
thing.
the holistic.
We also need to think about, I don't know how much time we have to talk, but like there's some physics where the forward propagation is different physics than the adjoint.
Yeah.
So only looking at the forward doesn't tell you the whole story.
I think you've just volunteered yourself for one of the tables next door.
Gerard, before we go,
Mark.
in terms of stakeholders, who's here? Do we have, I mean, Intel's in that process.
Yeah, fantastic question.
Do we have NVIDIA, AMD, cloud providers? Who are the relevant stakeholders?
So AMD are supposed to turn up. Where's AMD? Maybe they're just lost. So I see at least some cloud people are here, so that's awesome. And we've been working with them as well in terms of making stuff go faster, so that's awesome to see them there. Is there AWS here? I know they were interested in this as well. They might be in another room. Well, the reality is, I think who we want as a stakeholder is hardware, our cloud like providers, service companies, oil and gas, ISVs, and then I think it's a case of it's an open collaboration, so everyone is welcome to the party. And I think we're sort of going out on a limb trying to be, and we've got Intel. Sorry.
You do. You've got an Intel employee. We don't know about you having Intel.
Yeah. But yeah, that's a good question. So, and I think, frankly, if people aren't participating, they are important stakeholders. And I think if they're not participating, I think it's up to the community to encourage them to participate, because ultimately we're the benefactors in terms of getting faster, more robust code. And that ultimately is what everyone's looking for here. Okay, so guys, I'm going to try and get G to do most of the talking, because I'm actually getting tired of hearing my own voice. So we tried to sketch out roughly what we agreed on in terms of the roadmap. I don't know, John, do you want to say what time first? Do you want to just kick off the conversation in terms of the different types of models that we're looking at and why we're looking at them?
I can start. So at the top of this document, it says something like Chevron paid for the initial implementation or something. So last year, we started thinking about this, and I think it's worth saying something about the bigger picture. I have a talk at 1 o'clock where I'm going to say some of these things, but I think the idea is that there's going to be some kind of arbitrage system we're going to need that's going to tell us how to get the most cost-effective way to run the jobs we want to run. And things are changing. Hardware's changing. Software's changing. Spot availability market, the hardware availability, what types of VMs are available, all that stuff's changing all the time. So having something that's up to date, that's kind of continuously updated, that tells you how this problem runs on this hardware is going to be super important to us. And it's from talking with these guys today, I know it's important to them as well. So not everybody's kind of jumped into the cloud as irreversibly as Chevron has at this point, but it's a problem that I think we all face. So I don't know, we came up with a list of a few different classes of physics that we thought should be on this list of things we benchmark, and they include a simple one, isotropic acoustic, and then we get more complicated. The bread and butter probably for a lot of people, the service companies anyway, is going to be TTI pseudoacoustic, and then we move into a couple different elastic systems, one that's kind of simple and one that's more complicated, like TTI orthorhombic. And the idea would be evaluate how those physics run on different types of hardware. And I guess that's, we should listen to the other people talk. So that's the introduction, I guess.
Yeah. Okay, let's just follow the line. Mark, do you want to put your tuppence?
Yeah, I mean, I think John covered most of it. So I think there's a lot of things that we can do collaboratively, and also giving vendors an opportunity to understand what we're doing is actually really important. If we can give vendors an example of what we're trying to solve and agree between ourselves at a high level, at least what we want, then when GCP is going out and buying hardware, or AWS is going out to buy hardware, they have something that they can look at and see, okay, this is a problem that we need to think about how we can address this problem for the energy industry. I think that's helpful, and as well for the card vendors, the Intels and the NVIDIAs of the world. We don't want to all have to work out what all of the problems are, what the optimal compiler flags are. If they understand what we're trying to benchmark, then hopefully they do all of the hard work for us. And if that's captured in the DeVito platform, then we get the best performance with a lot less overhead on our side. So hopefully it will make our lives easier.
Yep.
strong agree on that, especially with the varying amount of rigidity in cloud SKUs and those sorts of shapes as well. We can start to instruct our ideal shape as SLB, but certainly when we have the momentum of a few other oil companies and other service companies too, that helps really illustrate the importance of the right sort of node shape for geophysics and that sort of thing. And me personally and SLB have been putting a huge amount of effort into our own benchmarks, and we've come to realize that our own software isn't always the best way to benchmark a variety of these things. We support such a wide variety of propagators and imaging conditions and different combinations of all these factors that having a more rigid set of benchmarks that we can look back and reference more consistently, I think will make a huge difference when it comes to future hardware choices and cloud choices.
Yeah, and I think John may well show some benchmarking he's done this afternoon, but we're not going to show any, but we have done a lot of benchmarking, and the number of benchmarking runs that we've run just evaluating GCP is dozens, right? Just to evaluate one algorithm, right? Realistically. And you know, it's a significant overhead just for a single hardware type. Well, not a single hardware type, but looking at, you know, a single vendor. There's multiple different cards. It is a complicated problem, and we don't want to have to repeat that for each company all the time.
Jeremy?
I also think one of the benefits of this is benchmarking with DeVito, because even if I'm just looking at different architectures and what their performance is, if I'm looking at benchmarks from the vendor and they've implemented it in their native language, it doesn't tell me if this implementation would take 6 months, if I would have to train someone in that architecture's native language to be able to get the same performance they did. If I'm looking at DeVito benchmarks, I'm looking at a high-level Python language that might be something I can implement in a day, and what the performance would be if I bought this architecture tomorrow and wanted to run things tomorrow.
Yeah.
Is Alex Morris here? Raise your hand. I'm calling you out directly. He's a representative of a cloud service provider. I know there's others here, but I'm familiar with Alex because we work with Azure. I think one of the things we hope happens, and now you can see there's building momentum. Everybody on the stage here is paying for DeVito Pro. Maybe not yet, but will be. And I understand there's more interest now. You know, there's evidence that a lot of people are interested in this. So what we need is the cloud providers to step up and say, here's one of each of these SKUs that we think are feasible for high performance computing. And you can, you know, run your tests on them. That's what we need to happen, in my opinion. Just to call you out directly. So the same applies to AWS and GCP if you guys are here too. I don't know if you are.
Yeah, I mean, the cloud providers is complicated because I'm not overly familiar with your exact cloud offering, but there's actual physical local disk on your GPU node, or there's block storage and things like that. There's a lot of components, especially when you go to the cloud, on how you configure the node, and they all have an impact on the total runtime. And yeah, and those are important to capture. And as customers, if you guys look at the problem for us, then it gives us a quick start. We can go and copy what's in the benchmark because that's been optimized by the vendors, whether they be the cloud vendors or the hardware vendors. And I think one thing we haven't mentioned is that there was an aspiration, I think, for the isotropic case, that there was going to be a really simple case that to potentially onboard new hardware providers, right? If you're coming up with some exotic hardware and you want to talk to people who might want to use that for wave propagation, for RCM, for FWI, that there's sort of an onboarding ramp as well, that you don't have to start off with a really complicated exotic geophysics. You can start off with something that's a comparatively simple thing to demonstrate the potential future value of a new hardware type. I think that's an important component as well, that we're not just looking at, that we provide a mechanism for people who aren't current vendors, but who aspire to provide solutions in the space.
Can I encourage maybe some questions from the audience? Like say, you made, sorry, I forget your name. Sean made what I thought was a good point earlier on in terms of using something like this also as a diagnostic tool for a bit of hardware and discovering. So is there other examples like that, or that's just a prompt for any general question from the audience, from this maybe system analysis people?
I have one more comment to make, and then I pass my microphone
Sure.
on, is that one thing we didn't talk about yet is that part of the benchmarking process will be some set of unit tests. That's one of my soapboxes I get on quite a bit, right? A test that prove that these things are correct, that they're doing what they advertise to do. So that's going to be baked into this infrastructure as well. I just wanted to mention that.
So we're not calculating the wrong answer more quickly.
Yeah. Who wants the microphone?
We're 87% friends, so we can share.
I do have the microphone. Can I ask one question?
Oh, shoot, yeah. Take the pressure off us.
No, I don't think so. How are you going to run this as a project? Who's going to track actions? Who's going to set deadlines? And how do we measure that we're hitting the marks that we all need?
Fantastic question. So we were trying to get this benchmarking off the ground, over the last nearly a year.
Mm-hmm.
And one of the reasons we were trying to do it was we have a number of intrinsic motivations. So we are an ISV, so of course we have got a vested interest in benchmarking, showing off our stuff. But it's also just the sheer labor, the amount of conversations we had to have with every company, and it's like having the benchmark conversation yet again. And so there's a very sort of high cost associated with that. So once Chevron agreed to, because we had to sit down, and this is a couple of months coding, even just to put together all the infrastructure and the basic tests and all the rest. I think we were sort of hoping that, okay, look, if we at least get the momentum going, like we talked on Tuesday about how do we encourage more collaboration, open collaboration. I think we sort of decided we had a sufficient degree of self-interest, that we were happy to push it and get it going initially. But then, frankly, I think we're failing, or we have called it wrong, if other companies then are not keen to get involved. So ideally, I think we'd like to organise this as something like a GIP. And one of the reasons you'd want to do that is so that companies also agree. So actually, this ties into one example. We are in a unique position because we're speaking to everyone. But then we have got NDAs also with everyone. So we know, oh, this person is having a problem with X vendor and hardware, and so is this person, and so is this person, and so is this person. But then we're not allowed to tell the people that they're having the same problem. Or we're not allowed to tell the vendor sometimes that a client is having a problem with their hardware because the NDA doesn't like us. It's a joke, frankly.
So I asked a big, broad question that I knew there was not likely an answer just yet, but throw it out as a challenge, not only for y'all, but especially for everyone. Mm-hmm. How do we think of this as one of our goals? How do we put it on our deliverable for the year? And how do we track that so that we do show project performance? Let's take it on emotionally for us to all invest. And let's go shame our companies into being open and talking, coming to, a regularly scheduled call. Mm-hmm. And, there's always some shame in knowing, hey, I promised to get this done before the next call. I'll start 4 hours before and I'll get something done at least.
Mm-hmm.
Yeah. I'm going to propose a panel of customers who want to harass vendors. Collectively. Mm-hmm. Anyone else? Someone from BP? Someone from Shell?
I'm not very combative.
But I think that's what we need, right? I think if we can form that panel by the end of the day, at least a commitment, a vague commitment, then I think we can go out and talk to people like the vendors and try and move things forward.
So there's a carrot and a stick. Sorry, I'll let someone else talk. Go ahead.
Yeah, I have a question. You talked about you want to keep track of performance as you get, test on different hardware. There's obviously other components to this too, which compiler you use, which libraries do you depend on. Have you thought about what aspects you want to keep track of, and if you want to keep track of this over time?
Yeah, so I think Joe is going to point to containerization and.
I can't read what's on the slide, so maybe it's already there.
So do you want to go ahead, Mark?
Okay, yeah. So in terms of metrics, we did have some debates on what we really wanted to track, because gigapoints per second can be a suboptimal metric when you start talking about expanding boxes and things. So what we're really interested in is wall time, and what I proposed as a matrix was actually just cost per shot, right? And that's ultimately what we want to get to, but it's kind of a bit of a stretch in some cases, right? Especially you have people like the card providers, and they're not actually, don't have a list price for how much an A100 is, right? And you have to go through HPE or Lenovo or whatever, and so that's not really realistic, but it perhaps is in the cloud environment, even if the list price might not be what's actually paid. But I think certainly we need to have what's really important, and I think is critical, is the reproducibility. So there's talk about having a script and GitHub Actions so that anyone can come along and reproduce exactly how the test was run. And if you couple that with sort of a container, then you could come along and verify that the numbers are correct and how much that would cost you, even if we can't actually bake it into a table.
Just made 88%.
Thanks.
Yeah, so you talked about the metrics. I was curious about what are the factors that actually influence that performance, right? So hardware is not the only piece. You have the drivers, you have the libraries, you have the compilers. Is that something that you could learn from that if you keep track of these things over time, right? And is that something that you would like to do, or is that not an important factor?
Yeah, so I think that was one of the drivers to have the benchmark and have the vendors involved in the first place, right? Anyone who's touched a compiler has at some point got frustrated. Like vectorization, why does something vectorize versus doesn't vectorize? And having the vendors be able to contribute to make sure that the benchmark figures for their hardware are correct means that they're going to make sure that hopefully the benchmark has the best practices with the best, the correct, in quotes, compiler flags for everything, right? Because, there's a finite number of things that you can actually keep track of as a benchmark, and I think personally I'm happy just keeping track of what the vendors recommend as best practice for compiler flags rather than exhaustively having a multi-dimensional matrix with every possible compiler flag. I think that's maybe a bit.
It would also be very interesting to see that difference from the first benchmark run out of the box, DeVito inside a container, standard options, versus some vendor influence to, correct some of that configuration and just see what that difference would be in the end, because it's not always very clear.
Mm-hmm. We should clarify about the OSS versus. Sorry, that one point that he made reminded me that I think there's going to be multiple benchmarks. One would be the sort of the vanilla open source DeVito, and then one would be something that's much closer to the production target environment. Mm-hmm. Sorry to interrupt.
I was going to say, I think I want to see 2 data points, right? One is the naive implementation, right? This is run in a container, default options with DeVito, et cetera. And if the vendors come in and say, this benchmark is wrong because you needed these compiler flags, you needed to add these variables, I want to see that. And I think that can also be a red flag if it's very difficult to figure out those options. If, the souped up version, fast version, required a lot of research on their end, that's transparent if I see those 2 data points.
And I think everyone on the panel would like to drive the vendor's optimized version and any configuration changes they had to make. We want to drive those into DeVito, right? Mm-hmm. and we want that to happen.
Yeah, because I think part of the advantage here then is you form a closed loop. So because you have the container, you have the full environment, you know exactly how you got there. And then if there's improvements, so we talked in our session about compiler bugs and issues with the vendor stacks. And there's bugs everywhere, okay? So we're sort of grown-ups here, we can admit that everyone has got some buggy code someplace. But then at least you have got a closed loop system where the bug then can be identified, fixed, fed back in, and just everyone moving forward with their life. Rather than...
Can I pull on the thread? You said something about over time, and we didn't really talk about that. Would we be measuring these, keeping all this data as a function of time so we could make a plot or whatever eventually?
Yeah, so currently, under the current setup, what we did is that we're just pushing everything. So we're using GitHub for everything, and that includes for the results. So we're pushing all the results to data repo. So the entire history is there, so you can see over time what's in there. So yeah. Well, yeah. So this is where we ducked. This is where we were able to avoid complexity exploding on us, because already we effectively have a database. It's called GitHub. It supports atomic updates and everything else. So all of that's taken care of, and you can interrogate it in for time. So, for example, you can go back through the logs in time and interrogate it in all these ways. So, in a sense, we were able to manage the complexity of all of this system just by build everything using GitHub itself as a programming platform. So yeah, so the ambition would be, and I guess this is a question then I've sort of maybe posed for the systems people. So we're taking very much a view on this in terms of the numerics and the benchmark. But if we also view this as potentially being a diagnostic tool, is there other stuff, is there other data that we could easily be collecting here at the same time? And potentially be storing that as well for doing differential diagnostics. We used examples earlier on where we had an on-prem versus a cloud A100, and we were able to use that to diagnose problems on the system. So I think the sky is the limit, right? You could be recording the temperature or whatever you want. But what's useful? But the question is, what's useful to store? Nothing. It's the end of all science. We have solved everything.
Settings do matter a lot.
And is that, so I don't actually know how to do that from the command line. Is this stuff that we could easily grab?
Some vendors, yes, some vendors no. Yeah, as long as you have root access.
As long as you have root
access.
Yeah. So all of this, I think this is the advantage here again in terms of reproducibility and everything else. Ultimately, the whole job specification is inside a JSON file. So I think it's in principle, anything is possible. It's only a question of what's useful.
But you should certainly like BIOS versions even, because even firmware versions are like HCAs on the cards and things like that. So it gets more challenging because you got to start tracking a lot more system stuff, even OS levels.
But is it more challenging if it's only a command? So this is why we want to standardize. Right. So if it's part of a standardized, then it's only one line in the JSON file.
Getting BIOS settings is always vendor dependent on your platform. You usually do it. You command line you do it.
But this is the point of collaborating, right? We have got lots of friends we can phone up and say for this task.
Just go look at the spec benchmark. All the things they keep track of.
Does this sound like it's useful to the general audience? Or are we just wasting time here? What do you think?
The systems guys, I mean, we've got just had a comment about, okay, we need to track a lot more of our system settings. What should we be tracking for you? What would be helpful for you? Do you want to see anything around I/O? You know, GPU utilization. I mean, what's meaningful to you? Do you think there are meaningful figures beyond, like, I mean, as far as I'm concerned, I want to optimize for runtime, right? But one of my concerns always with benchmarking is, okay, if you run a benchmark on a single GPU, that's never how we run stuff in production, right? We're always running 4 shots on a node if it's a single shot problem, and that has a massive impact on I/O to disk and things like that. And are there things that we're missing here that the wider systems guys in the other session think that, hey, you guys are totally missing something critical here?
From the benchmarking point of view, I mean, on the system side of the house, I like to use it for regression testing, just to make sure that changes we make to the system aren't degrading performance or introducing bugs. I mean, we've had file system updates that have introduced bugs. We've had InfiniBand updates that have introduced problems.
Yeah, testing new operating systems, new versions of CUDA. Right. You can just run a benchmark. We have a regression test. Passes, you're good to go. Roll out the update.
And collect the data over time. I have benchmarks from the very first time I deployed the system on the individual node level and at multi-node level to track a lot of it.
Which parts of the system configuration we need to keep track of?
Well, that's
everything.
Everything.
Everything. Actually, yeah. I agree.
Which API version you're using, which compiler version you're using.
And actually, maybe when you run the test, also maybe what's the temperature of the machine room?
Are you getting any throttling? Are you good power conditions?
Yeah, I guess there's a bit of a question there between bare metal and container, right? Because with a container, we're going to be capturing the compiler version and the CUDA version, but not the CUDA driver version. So the container itself is going to capture half of what you want, maybe.
Gerard, I think we're probably hitting a time when we
getting hungry. Oh, yeah.
we should break for lunch.
Yeah.
But I'm going to ask one question. Should this conversation continue beyond a day? Should we try to get as many of the people that are interested together in a month and keep the conversation alive, keep the whole community working together?
Ideally, yes.
Then why don't you and I take some responsibility and share the effort to find a way of creating that?
You should get one person from each company that's relevant here, right? Like all the cloud providers, all the hardware providers.
I think we want a single point of accountability from each company who are critical, and then have their buddies standing right behind them.
The whole thing is open source. You don't have to pay to do this. So get everybody from all the, one from each oil company and one from each service company.
We'll make that invitation for sure, and then let them forward the invitations inside their company. We'll put together a draft agenda. There's some people that, excuse me, I apologize, I was a manager for a while. I can feel people who are self-nominating to help with this. And so I can hear you, even though your mouth's not moving. Thank you for volunteering. Yes, I said I was a manager, but let's keep this momentum and keep this going, if you're okay.
Yeah, I think I'm okay, but there's a guy in my company that's in charge of like HPC, Alex, right? Maybe he should be the person. Anyway.
If you can upwardly delegate, bless you.
Yeah, okay.
But Alex is a good enough friend, I can shame him into helping as well.
But might have dodged the bullet.
No, I wouldn't go that far.